Welcome to Algebra 1. We today are discussing fractions, and we all know how wonderful fractions can be. So let's start by figuring out what is a fraction. So we have to begin with what in the world we're going to do. So let's write it. So in our today's objectives, are firstly to find out what definition of a factor is. Our solution is to write fractions in lowest terms. The third is to multiply and divide fractions. The fourth is to, of course, add and subtract fractions. Fifth is to solve applied fractions. So solve applied problems. Involving fractions. And the last is to interpret data on a circle graph. Now, because there's so many objectives, I'm probably going to be having to split this into 2 videos, and that's okay. So we'll cover first 3 objectives in the first video, we'll cover second 3 objectives in the second video. So we need to figure out first, what is a fraction? Okay, So a fraction tells us of a whole. Let me define a fraction. Is a numerical expression that tells part of a whole. Okay. So to translate that into something you can work with, it means how many of, let's say, like pie, because I'm thinking of food. So if I'm drawing a pie out like this, 1, 2, 4, I know if I have one shaded in, I have 1 divided by 4. That tells me I have 1 part of the whole, which is 4. Okay. Or if you like to think of it in terms of quarters, you have 25% of $1. That's a good way to think of it. For example, with this example here. So it tells me how many of the whole do I have. That's what a fraction tells us. I can have more than the whole, or I can have less than the whole. It doesn't matter. Okay. So I'm going to put that here. I can't. It is possible. You can have more than the whole, or less than the whole. Okay. So, in a situation where I would have more than the whole is, for example, 5/4. This is the part, and this is the whole. How much? In this situation, I actually have 5 pieces out of 4. And it doesn't make much sense. Actually, I'm going to erase this like that. So in this situation, I have 5 pieces out of the 4 total. And that may not make much sense to you. But basically what that means is I have more, I'm starting on a second piece. Or, the other way to look at it is I have more than what is necessary. Okay. So a good way to look at this, a good way to look at fractions when the top is bigger than the bottom is that you have more than necessary. In this situation, I have more than necessary. I only need 4, but I have 5, so I have more than necessary, like extra. Now, I can write a fraction in 3 ways. You see one of them, where I write it as top over bottom. Okay. So, I'm sure you remember all this. I'm sure you remember all of this. But a fraction can be written as a divided by b. A is the numerator, and of course b is the denominator, and b can never be 0. Of course, b can never be 0. So I can write a fraction in 3 ways. A divided by b, okay. I can write it as a divided by b like that. I can write b into a like that, like long division. So these are the 3 ways we can write fractions. I can also write it in words. So actually there's a 4th way. I can write a to b. So these are the 3 ways you'll see the 4 ways you'll see fractions written. More commonly we use this form. So this is form 1, form 2, form 3, and form 4. More commonly we use form 1 or form 2 in algebra. We don't really use this long division form anymore, although, yes, it's been a while since you've seen that. But you don't write it like that anymore. Okay? Now, that you know what a fraction looks like, we can work with the first objective. So the first objective is objective 1 is to define what a factor is. So learn definition of a factor. And to give you a simple definition of a factor to work with, we'll use the color purple. Since your book really doesn't give it a word definition, it just tells you that numbers are factors. Basically, a factor are any numbers you multiply to get a product. Okay. So any numbers that you multiply to get a product will be called factors. So for example, okay. And the numbers 2 times 3 is equal to 6. Now, in algebra, we use the dot multiplication instead of the x. Because x will represent later what we call a variable. But for now, you don't need to know that. In this situation, 2 times 3 is equal to 6. You recall all of this information. 6 is a product. And of course, 2 and 3 are factors. And you do not have to be limited to just 2. So you can multiply as many numbers as you wish to get a number. Let's say, for example, 3 times 4 times 2 is 24. In this situation, 24 is the product. 4, 3, and 2 are your factors. Okay? Everybody get it? The idea. The idea is that any numbers that you're going to multiply together are your factors. You can have more than one, you can have more than 2. You have to have a minimum of 2, but you do not have to have just 2. You can have 3, 4, 5, 6, 7, 9, 10, however many numbers you want, depending on how big the numbers you want to get. Okay? And this is simply definition of factor for you. And so we call the process factoring, or factored, when we determine what the numbers for the products are. Okay. Now, so your book defines it as the reverse of multiplication, but that is not, it's true, but it's not at the same time. So, definition of a factored form. As your book says, writing a product in 2 or more numbers. I don't want to use the pound sign for number because you might confuse that for hashtag. So, lest we get into the war of Twitter, here, back in my previous example, 2 times 3 in the factored form is 6 factored is 2 times 3, or 3 times 2. 24 factored, in this case I use 3 numbers, is 4 times 2 times 3, or 2 times 3 times 4, doesn't matter. Okay? Do that. So the factoring is the reverse of this. Is when we take the 24 and we split it into however many numbers we want. Okay? And then another definition to give you is prime numbers. Only have 2 factors. Prime numbers only have 2 factors. The number 1 and itself. So, for example, of a prime number, so it's usually nice to memorize the prime number system, or memorize the first few prime numbers that are so. So let's write down what these numbers are. And so I'm going to put this in a green box. Prime numbers, that's not the hashtag sign. Right, so your first few prime numbers are 2, 3, 5, 7, 11, 17, 19, 23, 29, 31, and 37. These are the first few prime numbers. These are not all of the prime numbers. And of course, the next one in this series would be 41 and then 43. Alright. So these are some prime numbers. Memorize these. So I apologize for the ugly box. But you need to memorize what these numbers are. So memorize them. Okay. So how many numbers do I have listed here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Memorize the first 13 prime numbers, and life will be good for you. Next point to mention and any number is to define what a composite number is. Okay. So a composite number is any number that can be broken down into numbers other than 1 in itself. So basically, anything that's not a prime number. Okay. Now, let's start by factoring some numbers. So let's figure out how to do that. Actually, what I'm going to do is go on to objective 2, because objective 2 will combine this point. We'll actually take care of what we're going to do here. Okay. So objective 2 is to write fractions in lowest terms. Alright, in order to write a fraction in lowest terms, you have to do two things. So this is the method. Okay. The first thing is that you cannot reduce it linearly. In order to write in order to get so the method to get a fraction into lowest terms, the first is to write it in terms of its GCF. Then the second is to simplify. Okay? Now, simplify if necessary, continue. If necessary, repeat. 1. Okay? So, for example, I want to try, let's try reducing, let's say for example, here. So for example, I want to write 12/20ths. Okay. That's the first example. How would I do that? So the solution for this. First, we're going to find the greatest common factor between between 12 and 20. So we do that by factoring 12 and 20. Okay? It doesn't matter how we factor them, as long as we factor them. Okay. So to factor 12, I want to figure out how can I rewrite it. I'm going to rewrite 12 as 4 times 3. I could have easily rewritten it as 6 times 2, or I could have easily rewritten it as 6 times 2, but 4 times 3 works better. Okay. And then I want to factor 20, which will factor as 4 times 5. Now I see the fact that I have the 4 in common with both. So in this case, 4 is in common with both. Right? So I can remove it. So to redo it, so the GCF in this situation is 4. So to rewrite it, 12 divided by 20 is going to equal 4 times 3 over 4 times 5. The 4's cancel. Now, be very careful. They do disappear, but they become 1. Okay? That's a very important distinction. Any number divided by itself is always 1. So any number divided by itself is always 1. It doesn't really matter. Anything divided by itself will always be 1, no matter what you do. Okay? So in this case, we end up with 3 divided by 5. Okay. So let me bust out a different color here. So 3 divided by 5 is actually the solution to the problem. Okay. So this is the answer in lowest terms. How do I know it's in lowest terms? I can't do anything else with it. So you see here, there's nothing in common with 3 and 5. It's in lowest terms when there's nothing in common with the top or the bottom, with the numerator or the denominator. Okay? Got it? All right, let's do another example here. We'll cover one more objective and we'll finish for the day. So I want to write in lowest terms. Let's say 12 divided by 48. So the same process that we did in last problem applies here. The same process applies. We need to find the GCF between 12 and 48. And then simplify. Okay? So the same exactly process applies in this situation. Now, 12 can of course be broken down into 4 times 3 or 6 times 2 or 12 times 1. Now you may ask, why did I leave it as 12 times 1? Because you're going to see something really obvious here with the 48. The 48 is split, is going to be the same thing as 12 times 4, right? There's 12 inches, right? So the person who's 4 foot tall is 48 inches. So the greatest common factor in this situation is 12. Not 6, not 2. Okay? So to rewrite it, once again, 12 divided by 48 is the same thing as 12 times 1 over 12 times 4. 12's go away, cancels become 1. Right? Anything divided by itself is always 1. So the answer is 1/4, or 1/4. So it's very important that you remember any number divided by itself is always 1. Remember that point. So it's always 1. Okay. Got it? Got it. Got it. So hopefully you guys are able to see that. You want to look for the largest number that is in common with both of them, and then you simplify it from there. Now, last objective for this video is to, of course, multiply fractions. See? Multiply and divide fractions. Okay, so we'll start with multiplying. We'll start with multiplying fractions. Okay, so first we need a definition or a rule. So the rule for fractions, the rule for multiplying fractions, let's get a red pen out. So the rule is as follows. If A over B and C over D are fractions, then A over B times C divided by D is equal to A times C over B times D. In other words, the rule can be simplified as simple. Multiply across. Okay? And then we always simplify answers in terms of their lowest terms. So whenever we multiply fractions, we always simplify the lowest terms. That's why we had objective 2. Okay? So how do we multiply fractions? So let's do an example. So let's multiply 7/9 and 12/14. Okay. So our solution for that is to use the rule. Alright, use the rule. Now, so to use that rule, so 7 over 9 times 12 over 14 is the same thing as writing 7 times 12 over 9 times 14. Now, I don't know about you guys, but I don't want to sit and multiply 7 times 12 and 9 times 14, even though I can easily do that. 84 and 126 respectively. But hey, if you're like me, let's say that and not do that. So I want to try to simplify rules using the fact using our ability to factor. So in this situation, what I want to do, or I can use the fact that I know certain things. Okay? For example, what's 14 divided by 7? 2. The only difference is that 14's on the bottom and 7's on the top. So what happens, instead of it going on the top, it goes on the bottom. So it's like 14 divided by 7, but reversed. So let's flip it around. So in this situation, I'm going to cancel the 7, cancel the 14, write 2. Now I'm going to put this in the explanatory notes that 14 divided by 7 is equal to 2. But 7 over 14 is going to be 1/2. So that's why I'll put the 1 right here. Did you already see how I did that? 14 divided by 14 is of course 7 times 2. So if you don't see that, it's 7 times 2. That's 1, that's 1, 1 times 2 is 2, and that's 1/2. So that's how I did that. Now, in this situation here, I have a couple things I can do. I know that 12 divided by 2 is 6, but hey, so I know that 12 divided by 2 is 6, but I also know that 12 is 4 times 3. So I'm going to take the 12 and split it into 4 times 3, or factor it to 4 times 3. So this is 4 times 3. I'm going to take the 9 and factor it as 3 times 3 times 2, from the 2 that's left over here. Now I can just look at it and go, oh, there's a 3 in common. 3 goes bye-bye. And now 4 divided by 2, that's a 1. There's a 2 in common here, and that's a 2. So this becomes 2/3, just like that. Does everybody see that? Now, I could have multiplied all this out and gotten 84 over 126 and gone all the way back and done it again, but who wants to do that? Because working with smaller numbers is always easier. So I'm going to write that in the explanatory notes here. Work with smaller numbers. Right, so now there is going to be an objectives quiz. We'll do dividing fractions in the next video. So an objectives quiz assures you that you're understanding what you're doing. So this was one's objective quiz. The first question I would like you to answer for me is to define a factor The second question I would like you to answer is reduce lowest terms. So 12 over 36, 9 over 81. And then the last I want you to redo is multiply (24 over 36) and 4 over 7 times 49 over 20. Okay. So these are your problems. There's 1, 2, 3, 4, 5 questions worth 5 points. And now for your homeworks. that you will do for me while you're so I want you read pages 2 to 4 in the 8th edition of the book. And then on page 10, you will do couple limbs. You'll do problem 7 through 39 odd. Okay? And of course, return the objectives close in the morning. Alright, so that's it for this video. In the next video, the next algebra video, I will cover the rest of the section, and then we'll move on to 1.2.